Hello, welcome. This is Mr. Mahoney doing the 1.2 practice set that we've got for AP Chemistry. And so we're going to first start off with calculating protons, number, neutrons, and all that. So the key thing here that I've also noted up above, let me grab my pen real quick, is that all of these are neutral compounds. And so that means that the number of protons, which is denoted by P plus for me, and the number of electrons, E minus, are going to be the exact same because they're neutral. We're just going to vary in the number of neutrons. So boron with a mass number. So remember, mass number, all of our mass in our center of our atom is going to come from protons and neutrons. Those are the only things that are real massive and are in the nucleus. And so that's what's really nice to know. Just by knowing that property, you don't have to necessarily memorize this equation because it comes from all these. So our mass number is going to be equal, this equation right here. Mass number is going to be equal to number of protons plus number of electrons. And so we know that it's boron, and so we know that on the periodic table it has an atomic number of 3, which is the number of protons in it. So atomic number is number of protons. Mass number is 11. Go ahead and solving for x, we can get that x is going to be 8 neutrons. So it's neutrally charged. We're going to have 8 neutrons, 3 protons, because of that 3 that we've got, again, right here that I'm pointing at, and 3 electrons. Do the same thing for bromine, is that we're going to have that 79 as our mass number. Finding on the periodic table, we have number 35. Solving for n is 44 number of neutrons. Again, because it's neutrally charged, we're going to have the same number of protons, 35, as well as electrons, 35. Potassium with a mass number of 39 is equal to 19 on the periodic table, plus the number of neutrons. And I'm doing N0 for neutrons because it's neutral. And we can see that that's going to be 20 after we solve for it, and again the same number of protons as well as electrons are going to be present. Calcium 40, and on the periodic table it is 20 for the number, and that's the atomic number, which is the number of protons. So that gets us with 20 neutrons. So everything is 20 in calcium. Iron is going to be 56 for a mass number on the periodic table, though it has an atomic number of 26 for the number of neutrons, leaving 30 neutrons. And 26 protons, 26 electrons. All atoms have similar protons in their nuclei. All the protons in an atom's nucleus are positively charged very close together. What is strange about this? What is strange is that they're similar charges, but that they're not reflecting each other. Because we usually see that like charges are going to repel each other, but these are actually coming closer together. They're condensing down in the nucleus, and they're staying there. So that's what's kind of strange that we've got going on here, that they meant by that. So they wanted you to draw something very similar, not necessarily to this whole thing, but to the cathode ray tube that they had going on. So you have to have like the tube. You don't have to have the alligator tip in the stand, but they want you to show the tube, they want to show the cathode, the anode, and how it all travels for the electrons. So we've just completed a laboratory experiment in which you produce magnesium oxide from metal and oxygen mass. So we can see here that we obtain all these results. And so the biggest thing here is that mass is always going to be conserved. We can add up all these things. That mass is always conserved. So that's all they wanted you to know, is that mass is always conserved. And that's how much is remaining or not remaining, is that they always add up. And so that's the biggest thing here, is that we cannot create nor destroy matter. Great. Well, this has been the 1.2 homework set that we've got for AP Chem. So if you have any other questions, please go ahead and let me know. Other than that, have a great day.